Okay, we're going to go ahead and get started here. Thanks, everybody, for staying around until 5 p.m. today. There's more to come after this. So this talk is over high-level malware. This is Chris Truncer.
Hi, so I'm Chris Truncer. I've not always worked in security. I previously started as a sysadmin and have since been lucky enough to make the jump into security and do red team work with this guy. I'm a proud Florida State Seminole in the land of Miami, so go Noles. No, I don't like you back there with the U. I'm an open source developer. I worked on a variety of different projects like the Veil framework, Egress SS, which I actually spoke at HackMiami last year on with a previous presenter, Steve. Eyewitness, Just Metadata, and so forth.
I'm Evan Pena, work for Mandiant. I'm the West Coast Red Team lead, and I'm an open source developer as well. Released a couple of things shown up there, and I have a few more that are going to release after this talk as well. Actually, they're already released, so you'll see them. There will be links at the end of the slide deck so you guys can see that as well. So what's this talk about? It's pretty much just about how malware generally works, and we talk about some injection basics using shellcode injection, process injection into memory, and then we'll talk about some client development basics, meaning what you develop in a client that's going to be put on a victim machine, and what should you develop on a server that's going to be put on your machine that you can control your client. We'll talk about some A/B detections and how you can mitigate some of that. And then also some sample custom code that we've developed so you can see how you can use them as stagers and other initial points of entry.
So one quick thing. There's going to be a lot of pictures of code and certain functions that we're using. Don't worry about taking pictures. We've literally just uploaded all of these slides. It's on our Twitter account. So you can just use those for reference and not have to worry about trying to really quickly download stuff or get the URL.
All right, so some of the basics. Most traditional malware is a standard client-server model. So you will download and execute a piece of malware on a victim machine. That specific malware is waiting for callbacks from the C2 server. So that server is going to be sending some sort of command to the client that's on the victim machine waiting for instruction. This can be done periodically. It could be done every second. It could be done every hour. It just depends on how you configure the client to wait for server communication. So other variants. There's worms, ransomware, logic bombs. Worms will self-propagate, trying to spread throughout your network. Something like ransomware is generally a type of malware that attackers will use to ransom your network. So let's say, for example, they have all your PII, and they say, hey, look, we're going to release all your PII to the public if you don't pay us $500,000. It could also be, if you don't pay us $500,000, we'll just destroy all your data and your backups, so everything that you have is going to be gone, and it's going to take you more than $500,000 to recover that. So you're enticed to pay us. That's the kind of thing for ransomware.
So this is like what's been in the news lately, like Lockheed and a bunch of different hospitals that have been infected by something like that. We're seeing a surge of this malware all over.
As far as motivations, a lot of attackers will use malware to mainly gain access to your network and look for specific data. Like nation-state attackers will look for certain things like intellectual property so they can reuse that and create their own type of product. Other things like other nation-states, for example, will try to steal credit card numbers and then recreate those and just steal a bunch of money. If there's nothing to get, they'll just resort to ransomware and just threaten you and to try to get money that way. As far as logic bombs, any of you guys see the movie Office Space? That's kind of like a logic bomb where they have a specific piece of malware on the network waiting for something to happen that's going to constantly be doing something as it gets instructions. Other ones can be a disgruntled employee that ends up leaving on wrong terms and they get really upset. They put a specific malware on the environment that waits for a specific date or event to happen and then destroys something.
I remember there was something in San Francisco. I can't remember if it was like an actual logic bomb or whether you just changed stuff. But it was like an old, there's like a Cisco administrator that was like recently fired or let go right before he left. He changed all the passwords and all the network infrastructure, and he was like basically helping them have until he either provided like either the password or the key to his malware that decrypted everything so they could actually leverage it. It's rare, but it's still kind of
Never a good thing. You always get sent to jail if you get caught.
yeah.
The worst thing to do is don't put your name in the metadata or anywhere associated with your malware. So what do we normally use? We use a similar client-server model, just like what we talked about before. Some commodity-based malware that's open to the public that probably a lot of people are used to is Metasploit's Meterpreter shell. Also Cobalt Strike's Beacon, or just custom code if you decide to write something on your own so you can get past AV and different products like that. We don't enable things to self-propagate. Reason why, like a worm for example, is because we like to control what we're doing. If I program a specific piece of malware to kind of self-propagate throughout the network, I don't always know where it's going to go, what it's going to do. It could get detected. It may traverse firewalls. And traversing firewalls may traverse different other detection mechanisms like IDSs. So I like to personally create malware that doesn't just go spread and auto-pwn everything. Because again, that could be a bit noisy.
Yeah, none of us like malware that turns into Skynet and just starts going.
Yeah. We also don't like to do destructive actions. One, because we'll probably get fired from that client. And two, because there's no real glory in destroying things, in my opinion. You can destroy something all you want and laugh at the end of the day, but it's going to be harmful to your client, and you're probably not going to get hired back.
And this can be like destruction in the sense of like actual data or like network traffic. A previous place where I've been, someone decided to arc voice in the whole network, realized that it dropped their machine to basically like an unusable state, and rather than re-arcing the network to fix everything, they just shut their laptop. And so the network was like shot to hell for 30 minutes until everything could finally get going. And you could say the customer was not very happy. So this relates to both like network protocols and also includes data.
So most of the malware we're used on assessments are generally just going to help facilitate access and execute different tasks. Tasks can be something like process listing or download and upload files, just basic domain enumeration, things like that. So rats. When we're breaking into the system, it's very likely you're going to encounter antivirus. If you're using commodity-based malware, such as the ones I talked about before, Beacon or Metinterpreter, if you just use the raw payload that's generated, you're going to get caught by antivirus because there's a signature for every single one of the commodity-based malwares. So how do you get around this? You generally write something of your own. A big reason we're doing this talk today is kind of to release certain code that you can use initially that will allow you to bypass antivirus and inject commodity-based malware into memory. We'll talk about that in a little bit. Other ways that you can do this are using like Packers or even the Veil framework, which Chris created. And those are pretty good, but they don't always work. Sometimes they'll get caught every once in a while because they create and update signatures all the time. So again, we'll go through some of the techniques that you can use to get around that. So what should a rat have? Or again, when I say rat, it's a remote access Trojan. Just think of it as a backdoor or some piece of malware. So what should it do? Command and control communications that check into a server. Ability to execute command line commands, which means if you're on Windows, for example, you can type dir and you get a directory listing. If you're in Linux, you type ls, you get a directory listing as well. Ability to inject shellcode or the ability to inject shellcode into a remote process.
And so that's like probably some of your super basic functionality. The shellcode injection, maybe some people don't find it before. We've used it, or I've used it a lot, and it's been helpful where I can leverage maybe my initial rat to get a better rat that I want actually injected on our system. But this is kind of what we start for. It's going to be dependent upon your client. Like what's your goals for the operations you're performing? Like what do they want you to do, and what?
As far as server functionality, one thing to note is like if you have a server, let's just say it's on listening on an IP address, and some sort of incident response professional identifies that IP address and they browse to it via like a web browser, it shouldn't be obvious that it says, hey, this is a C2 malware server. So generally something like some obfuscation, what we like to do is just throw back a 500 internal server error so they stop, or maybe it just hinders their investigation. Anti-replay detection or prevention. This is something like if, for example, I saw someone browse to that specific IP, I have built into my malware agent that it will look, if it did that once, then it will use a different IP address for a different C2 server. So that way I try to hinder the incident response professional from going back to that C2. Also, tracking and manage multiple agents. It's likely that if I'm a really good attacker, I'm going to compromise multiple different systems on an environment, not just one. And then handling data by the agent to submit it over the wire. This is, again, file upload, download, output of different commands that I send, stuff like that. This is basic server functionality.
Yeah, this is, I mean, well, we don't use Metinterpreter all the time, but like how they okay, shellcode injection. So we're going to get a little technical with this stuff, but that's because we wanted to get kind of the foundation on how this works, and it'll lead into the malware that we're releasing today so that you guys can learn how it works. So shellcode injection is typically performed by stagers anytime, like if you use a veil evasion payload or like MSF Venom to create an XC, let's say. The point is you don't have Meterpreter in that. It's to basically download this reflective DLL that is Meterpreter and to run your RAD on your system. So the cool thing about stagers is any language that has access to the lower level like Windows API, you can write a stager in. So the typical like standard ones probably like C, C++, C#. However, like Veil uses, we can access it with Python, Ruby, PowerShell, Perl, pretty much any language that allows you to have those same function calls you can use to create your own custom stager. This sounds kind of complicated, but it's really only 4 function calls that you need to actually write your own. The main concept behind how it works is you're just allocating memory for where you want to store your shellcode. You are copying the shellcode that you want to inject into memory into that memory space. You're then creating a thread, which starts a thread right at the start of your shellcode, and so it executes it. And then the final thing is you wait for that thread to run and exit. So your program just doesn't close right away. It waits for Meterpreter to run, and it'll keep running until basically you say Meterpreter exit or kill the session, and then it'll stop. So the 4 functions in this case that make this happen is virtual alloc. This is probably the main one. You could also use what's called heap alloc. But this is what actually allocates memory. And so the main info, I'm not going to go through all of these because you can see it from the slides. But the big important things are like how much space do you need to allocate in memory. So that's like the size of your shellcode. And you're going to give that information to this function. And the other main thing is what permissions do you want to have on your memory. So you could have it read-only, but then you wouldn't be able to do anything with it except read the data that's in it. In order for us to actually write shellcode to memory and then execute it, we need to mark that location of memory as writable and executable. RTL move memory is the function that actually moves our shellcode, or that we use for Python payloads to move the shellcode into that memory space that you created. The main thing that it takes is the location of memory that you previously just allocated, the shellcode, and then the length of the shellcode that you're going to move into it. Create remote thread is exactly what it sounds like. It creates a thread based off of that memory pointer that you give it, and it will run your code that you injected into memory. The final thing is wait for single object. And so this is what's going to tell your program main, essentially, don't exit out. Let that shellcode run and run to completion before the whole program exits. And so this is this is kind of tiny for this room. This, again, is going to be released online, so you'll be able to look at this later. But to give a quick description, this is how it works. So this is just a big bunch of shellcode, and this is Python. And so this is what we're going to inject. And this is actually a Meterpreter shellcode, or MSF Venom generated shellcode. C-types is that library that allows us to interact with the Windows API. And then basically we have just all the different calls I just talked about. So we have virtual alloc, which is allocating the memory. We have RTL move memory, which is moving the shellcode into that memory that was just allocated. We have create thread, which is creating a thread to execute all this shellcode. And then finally wait for single object says, hey, let that shellcode run and to completion before we kill the whole program.
So you can do the same exact thing in C#. The only difference is instead of RTL move object, .NET has this Marshall library, which has a copy method within it that you can just use to allocate the memory or move the shellcode into memory. So same API calls as the ones Truncer was talking about. You got virtual alloc, create thread, and then wait for single object. And once you just copy it into memory, you can do the exact same thing as you did in Python, just in another language that's pretty simple. So let's say you're like, oh my gosh, this shellcode, it looks really ugly. How would I ever be able to write that? No one's going to want to write their own shellcode. It's just not really practical. So what you do is you just use things like MSF Venom. So the whole idea of this is you can use something like Python and just like 8 lines of code to inject shellcode into memory, and Python being custom code to what you want it to be. So if, for example, you wrote your own shellcode injector, which is likely going to bypass the antivirus, then you can use something like a fully functional rat like Meterpreter to inject that shellcode into memory, it remaining in memory, not being touched to disk, and bypassing antivirus. That's the whole idea of this concept. Same thing with C#. Another cool thing to note is if you guys are using Cobalt Strike and you're using Beacon, you can actually set a listener in Beacon. Let's say, for example, it's HTTP or HTTPS. It also has like a multi-handler for handling Meterpreter callbacks. So if, for example, you create the shellcode in MSF Venom for a reverse HTTPS or reverse HTTP shell, and you have a Beacon listener listening on those same protocols, it will actually handle the callback. So kind of a neat tidbit if you guys didn't know about that.
All right, next up is process injection. So this is going to be pretty similar to shellcode injection, except the main difference is you're not allocating memory in the process that you're currently running. It's in a remote process. So let's say I'm in chris.exe and I want to inject into putty.exe. You're able to do that as long as you basically have the same, it's running at the same permission level versus you're a low-level user and that's like administratively run. This is also done in 4 steps where you're just obtaining a handle to the remote process that you want to inject into. You're allocating memory in that process. You're writing the shellcode to it, and then you're creating a thread within it. Oops. Okay, and so in order to do this, again, kind of like what I just said, it's open process is the function that you're going to call. This is going to give you a handle into that remote process, assuming that you have the same security level as the process that you're looking to inject into. So for example, I couldn't run something as a low-level user and then try to inject into LSASS because that's going to essentially be kernel level. Virtual Alloc X, which is basically the same thing as Virtual Alloc, except Virtual Alloc X is used to allocate memory in remote processes. So this would take in a handle which was returned by open process, allocate memory in that remote process, and it's, again, going to take all the other same information, like how much size do you need allocated? What are the memory protections that you need for that specific piece of memory? Write process memory is what we use to then write that shellcode into a remote process. It takes a lot of the same information, again, the handle to the remote process. It takes the length of the shellcode that you want to inject and then the actual shellcode itself. And then the final thing is create remote thread. And so this tells that remote process, hey, within that space that you just got allocated, that you have the shellcode in it, also run this thread. The main difference here is we don't have to do the wait for single object because this is already running in a remote process. The downside would be if that other process, such as putty or whatever, were to close and exit out, then this thread would be killed. And so this is what that kind of looks like. Again, we're using C types to import everything. Here's our shellcode. In this case, we're just asking to get a handle to process with the process ID 1234, and then it goes through the same function call. So we have open process, virtual alloc X, write process memory, and then create remote thread.
Again, the same thing done in C#. The only difference is you might notice that there's an additional call for close handle. The reason is because at the very end of doing the exact same thing Truncer did in Python, but in C#, I closed the handle to that specific thread. One thing you'll also notice in this is that I have a process ID of 2636, which was actually notepad.exe in this specific case on a 64-bit system, which is a 64-bit process. In my case, I was trying to inject a 32-bit shellcode Meterpreter shell into the 64-bit process, which obviously will fail. So something to note, if you guys are doing shellcode injection, make sure you have the right architecture that you're injecting into the right process.
I can't tell you how many times I've basically made that mistake, where it's kind of like Burp Suite, where I use Burp Suite all the time on web app assessments, and I'll be testing a web app, and then I'll shut down. Then the next day, I'll try to just browse the internet, and I have no idea why I can't access it. Well, it's because my proxy isn't up and running, because the Burp Suite hasn't changed that. So it's kind of like this same sort of thing that's not a proxy, but I've always tried injecting 32-bit shellcode into a 64-bit process. It'll never work. It'll just crash. So that's something, if you're looking to do this sort of thing, that you can look out for and maybe try to do some detection. Last little bit of code, I promise, that we're going to try to talk about is just key logging. For this example, we're just going to do a Python-based keylogger. It's actually really simple, and the nice thing about Python is it can obviously be wrapped up into an executable. There's a couple different tools out there that do it, like PyInstaller or Py2Exe, and that works by essentially taking the Python interpreter, packaging up with the script that you're looking to wrap up. It's not really compiling, and then it'll make an executable, which is essentially an archive which self-extracts itself, calls the interpreter, and then runs your script. The cool thing about this is there was already public code for this. There's really public code for almost anything that you want to do, so you don't have to do a lot of work from scratch. You can start from someone else's work and modify it. And that's what I did with this case, or in this case, where I just made some small modifications to the keylogger in order to work on my system. The cool thing about this is this will work from user level land. You don't need admin level permissions in order to run a keylogger and log the output to your system. So the way this works, I'll just kind of speak through this. Again, I'm going to apologize ahead of time for this being really tiny, but you can check out this code on our slide deck, and we have links to everything to get the actual code. It uses something called PyHook, which is a Python library that essentially hooks right into the Windows OS, the core OS, and it looks for any event. And so an event is basically like a mouse click or a keyboard button being pushed. And so what this code does is for any event that comes in, it checks to see if it's a ASCII character or like shift or something like that, or a symbol. And it will then, if it's any of those, it will write that out, in this case, just to my downloads folder in a file called output.txt, and that'll be it. And so this basically just runs silently in the background, and as you type into Notepad or access web URLs or log in a username and password, this is actually logging and storing the username and password right to disk. The cool thing about this, again, is that it doesn't require any sort of administrative rights to do it. If you're looking to just target someone, we've done attacks where we're able to get on maybe a Linux administrator's machine that's on a Windows desktop, and so we can basically get up some sort of keylogger running, kill PuTTY if that's like their SSH client of choice, and then wait for them to log right back in, and we're able to get their username and password and jump from like Windows to Linux land in that case.
All right, so you've heard us kind of talk about a little bit of Python and C# shellcode injection, process injection. Now we're going to kind of go into some malware, like full-blown C2 malware. So some of the malware agents need to be able to egress certain certain networks. An example is, let's say, for example, you have your malware installed and executed on a victim machine that is not allowed outbound on any specific ports. Or maybe it's only allowed outbound on DNS. So the malware needs to be able to think, okay, what can I get out of the network with? And then change the protocol to be that, whether it be DNS, HTTP, HTTPS, for example, or it needs to be proxyware. If you have an internal proxy that it can authenticate to and then connect out through the proxy, it can do that as well. These are kind of basic functionality that most malware agents should have. Secure communications are very important. If you are sending data out into the internet, like to a C2 server, and it's in the clear text and you're stealing credentials, those credentials could be exposed to the internet or in clear text. That's never a good idea.
Yeah, your customers aren't going to be very happy when you're running DNS and dumping their DA passwords over clear text.
And it needs to have C2, essentially just a way to receive commands from the server. And most importantly, evade antivirus, because if antivirus catches it, quarantines it, and you have no communication at all. As far as server, again, I already talked about it not being able to stand out as a C2 server. So like a landing page saying I'm a C2 server, never a good idea. You have to protect against replay attacks. I spoke about that as well. Ensure communications, just like I said, nothing in the clear text. And being able to track multiple agents using individual commands as well.
So let's say for like protecting against replay attacks, one thing that I have a small little rat that I wrote that talks back over HTTP or HTTPS. And it goes to a single IP address, but then the URI is kind of dependent upon like which agent it is and if it's actually allowed to check in. And so the way I have this work is the agent and the server have a pre-shared key, and they iterate basically over that to create about 10,000 good or whitelisted URIs. And so every time one of them is used, that URI is taken out of the list and can never be used again. So what that kind of protects against is, let's say some IR or blue team is able to capture network traffic or see what they think is the agent actually connecting out to a C2 server. Because maybe if it's a URI and it's a hash, maybe it stands out as a little weird. If they were to then browse to that, you're not going to actually get any commands because that URI has been removed, and you can configure the server to essentially blacklist or block that IP or do whatever defensive actions you would like it to do to protect yourself from IR guys looking into it. Oh. AV detection. Okay. So I'll talk a little bit how Veil kind of does. This is AV detection kind of evasion. This is a standard payload for Veil. So we have a ton of different kinds that are in there. We have encrypted ones. We have obfuscated ones. This is what I call like a flat payload. And so what that means is like, so I was just talking about like virtual alloc, RTL, move memory, create remote thread, write single object. This is literally in the Python code that's being generated and packaged into an executable. So if you ran strings on the executable, you're probably going to see it. Like it's in no way obfuscated. So from my perspective, it's probably should be one of the easier types of payloads that AV could detect. And so again, this is what I was talking about. That's exactly what it looks like, where that information and those function calls are right in here. So when I started, it was probably about a year after we released Veil Evasion that everything went by without a signature. I mean, I constantly ran it everywhere, like this payload, and nothing caught it. It was about a year in, I think it was McAfee that actually found and created their first signature for this. And so it was kind of fun because we're like, okay, now starts the cat and mouse game. Let's see if we can put our money where our mouth is and actually try to evade a couple different types of AV. And so I started looking into the code and trying to figure out how it works, like what maybe they're keying off of to do the detection. And it turned out it looks like it's based off of the C types that I was talking about. And this is specific to the Python payloads because that's what we use in Python to interact with the Windows API. But if you see, C types is everywhere. And there's plenty more that I haven't highlighted in this picture, but it's all over the place. And so they're probably, in my mind, I was guessing, they were looking to see, hey, is there this like import C types in this code somewhere? And is it being used in correlation with like virtual alloc, RTL move memory, or anywhere else that it's being used in this code? And if so, then that's probably how they're keying off of that it's a virus generated by Veil. So when that happened, I wanted to figure out, okay, let's do some like super quick testing. Let's see if I can bypass this in any way. What this is right here, this is the git diff, essentially, from my commit that was from what it was to what I wanted to do to see if it would bypass antivirus. And what I have right here, Python has this really nifty thing, in case people don't develop in Python, where you can alias like libraries that you're importing. So I have import C types was in the original code, and then anywhere that it was used in my code, I had to call it C types. Well, I can just change it to import C types as AVLOL. And then throughout the rest of my code, I literally just did a find replace on C types and just replaced it with AVLOL and put that right in. What do you know? Right after I changed that, it came back as safe. There was no longer a virus. So this was really simple to change and modify and to get to bypass AV. And so this isn't just McAfee. This is a lot. This bypass, that tiny change bypass, I think almost every AV product that was out there that had slowly started to signature it. So I wanted to talk about it just to show doing like the smallest modifications to your code, if it's somehow catching it, can sometimes really easily result in an AV bypass. Like this is just literally a find and replace. There's a lot of PowerShell stuff out there, like Invoke Mimikatz or PowerView or PowerUp that sometimes get caught by different AV vendors. You can, for those, a lot of the times, at the very top of most PowerShell scripts, there's like comment headers where it gives like the author's name and a description of the tool. You can literally just delete the comment headers right out of it, or just sometimes even removing the author himself, and such as Gentle Kiwi, the guy that wrote Mimikatz. You can remove his author's name, and all of a sudden it bypasses AV when you're writing to disk. So I was going to talk about, I kind of failed when I wanted to do, was preparing for this presentation here. What I really wanted to show and do was come up with a live AV bypass just to show, again, how easy it was done. Because I've been told that right now for certain AVs, it's catching veil. And so I wanted to demo that. And so I was, again, going to start off using, hey, this is this flat payload that has no sort of obfuscation or encryption at all inside of it. And so I was like, this is probably, again, going to be the easiest and like the first thing that's going to get caught out there. So I created this file, chris.exe, and I was like, okay, this should be pretty simple. It's going to catch it. Well, you can see I wrote it on disk and nothing happened. So it was really kind of weird. And I tried running it, and I did get my handle or my stage sent, and I actually opened up an interpreter session. So I didn't know what was going on, and what do you know? I'm still scanning it right now with this code. This is probably as of a week ago or 2 weeks ago. And both McAfee and Norton, in this case, are saying that the code's completely clear. So I really wanted to try to demo some sort of AV bypass, but unfortunately, with these two different technologies right now are still bypassing it. So sorry, guys. Oh, sample custom malware. Okay. So now we'll get into a few case studies of pieces of malware that we wrote. This was a cool little one called Enumerator. I don't know, we didn't really have a name for it. In this case, we had a client where they wanted us to fish our way in. When we fish our way, I'm speaking, everyone in here knows that when you fish your way in, there's always someone that's going to click something. There's no point in really harping on that. So this client wanted the proof, though. However, they didn't want us to run any sort of like shellcode injector. They didn't want active beacons or interpreters that are going into their network. So at first we didn't know what they wanted. But they said they wanted more than just statistical collection to see who was clicking on it. So we came with this idea of this tiny little script that is called Enumerator, where what it does, it gathers intelligence or information from the systems where this runs. And so this was designed to essentially enumerate information such as the username that it's running under, the domain, the system identifier, so the host name and the domain that it's running in, process listing, what drives are on the system, stuff like that. And it kind of worked out because that would provide them some information like, hey, yeah, we have actual proof that this is running inside our customer environment. But also, if they then have some information where they can see, okay, people that are falling to it, what systems would actually be impacted if this code was run? Like, it's a kind of a true test without actually injecting malware into their environment. So the agent code for this is actually really, really simple. Right here, it's basically just a hard-coded URI, or IP and URI, full URL, essentially, where it's reporting back to. It's essentially just getting the system's IP address and then the full host name, so that's host name, domain, etc. And then the next part, all I'm doing is just enumerating the different drives. So there's a couple real quick function calls through C-types that you can list every single drive on the system, and then you can also get information such as like how much space is on that drive, just random stuff that our customer might want. Then the last kind of main thing that we wanted to go for was to get the task list output to see what processes are running, just as some like extra information for proof to our customer. Just like, hey, this sort of information's on there. We're able to get it, an attacker could as well. So basically, after all that was done, we're wrapping that up and we're posting this out of the network. In this case, there wasn't a proxy, so there's no proxy support really added into this piece of malware. It's not even really malware, it's just a script. But if you needed to, it'd probably just be a quick line or two to get that added into Python. And then right now, all it does is just post that data out over HTTPS to our systems where we are listening. The server code is also really simple. There's this Python class called base HTTP request handler, essentially. And you can handle based off of the type of web request you have coming in. So this is either, is it a GET request or a POST request? Since in this case, we're only accepting POST requests, the first thing that we have is if there's a GET request coming in, we want to alert ourselves and let us know, hey, either you're getting scanned or maybe someone found this, reported this to the internal security team, just a heads up that is kind of being looked at because we're not getting the responses that we expect. If we have a POST request, the first thing that it checks then is this to the URI that we expect? And so we only hard-coded one URI, which is this post enum data. So as long as that's in the right, it's coming to the right URI, we send it basically to 200 response. We just gather all the data that is being sent to us from the client, we create the current date and timestamp of that of the data coming in and write that out to disk, and then that's about it. If it's sent to a different URI, but it's still a post request, we again then say, hey, this is odd, you should look into this, or just be alerted that someone's trying to investigate your system. Something a little weird is going on. Finally, it's all just essentially a web server. Like right here, you can we're providing a certificate to help ensure that our communications are secure, so it's all talking over HTTPS. And then this is all threaded, so we can handle multiple agents checking in and sending data to us all the time. So I want to just kind of really quickly right there give you guys that walkthrough on how it works. This code, again, is online, so you can just take this immediately after a presentation and use it or modify it to however you see fit if it would work and help in your environment. Agent side, right here I'm just running it in Python, but when we package it up, we use PyInstaller. And the cool thing about PyInstaller is you can say, hey, don't provide a console. So if this was actually executed by a victim, all they're doing is running this executable. They see nothing pop up. There's no window or anything like that, and they probably just delete it and go about their way. But really, at that point, it's enumerating all the information from their system. And then server side, we can see, hey, we're listening, and look, we've got this post request that just came in at the URI we expect from this IP address. And so in this case, this is the data that we got back. So we have the system host name and the domain. In this case, it's just local domain. Any IP addresses that that system may have associated with it, the drives in their free space, the current user's username, and then a list of processes that are running on their system.
All right, so I'm going to go through a reverse shell that was written in C#. One thing I want to caveat is that this was originally written by a guy named Paul Chen on a source code project that I heavily modified to include shellcode injection, shellcode process injection. So we'll kind of go through the steps of what I did for that. So the code is pretty simple. It just instantiates a stream reader and stream writer. It has a connection listing, in this case, to localhost on a specific port. And it invokes CMD so that the server that it connects to can interact with cmd.exe and issue commands. You'll notice on the very bottom, as commands are being sent to this specific agent, it looks for things like shellcode or process inject so that if it sees those strings, it does something else, which would obviously invoke shellcode into different things. Otherwise, it would just issue the command send for cmd.exe. So on the server side, very similar. It's just listening on that specific port so the agent can connect back to it as a reverse shell would. And again, it invokes the stream reader and stream writer, and so you can issue commands to the agent itself. So this is kind of what the GUI looks like. As you can see, it has a connection to localhost. I'm just listening on a localhost in this case. In this text box, you can put something like, in my case, I put a dir and hit enter. So I got a directory listing of the specific directory I was in, which is essentially the development folder. So obviously on the agent side, you can't see it run because it's a hidden console. So you don't actually do Python and then space and then execute it. So in this case, I have an example of me injecting a interpreter reverse shell into memory using shellcode injection. So as I told you before, I added a shellcode parameter, and then you just hit space and put the shellcode you want to inject. So in this case, it's listening over here in a interpreter multi-handler. And then when I inject the shellcode in, you get the callback right there. So again, this is a really good way to just use something and modify it heavily so it bypasses any AV, so you can inject a fully functional RAT into memory. Again, bypassing AV, nothing touching the disk. Another thing to note is that this is a pretty simple reverse shell. It just issues commands to cmd.exe. You can add different functionality like I did if you wanted to, but this is meant to be a stager, kind of like an initial access, so you can do something pretty quickly so you can get a more fully functional RAT later. So certain things to note. I like to use something initial like this to mainly do some recon and enumeration on the domain that I'm on, maybe add a user account if I absolutely have to, or maintain persistence on the network itself. Again, this is more like initial things that I want to do really quickly with a specific tool that I can modify heavily. So that's the whole purpose of this specifically. So another thing that I wrote in C# was called dark link. And this is some really simple stuff, but it was quick and easy. And this is a very similar concept, is that it allows you to download and execute a specific payload that is designed to be a more full-featured RAT, and it will persist that payload for you. And the way that it will do that is it looks for specific folders, and then it will create a scheduled task, or it will modify the registry. So you can modify this code too to do, maybe modify the registry first and then create a scheduled task if you can. Or you can do one or the other. I've released this code out to the public, so it's pretty easy for people to modify. Again, it being something that you can just use initially to persist something quickly, and then maybe you can do a more advanced persistent mechanism later, like using WMI or something like that. So what does it do initially? It will check. Notice how I do the check folders first. First, it sees if you can connect out to the internet. If you can, it doesn't do anything. And then if it can, then it will download your payload, and then it will check folders. The folders that are checking for are commonly used software that are on systems, Adobe Reader, Adobe Flash, Java. And it actually goes through every single iteration of the version. In this case, I have 10. It will look for 11. It will look for 9. It will look for 8. It sees if any of these softwares are installed. If it finds one of these folders in place, then it will create the respective executable associated with it. So let's say, for example, I found Adobe. It'll create Adobe Updater.exe and then create a scheduled task that updates Adobe. So it looks fairly legitimate, but it's obviously not. So this is, again, just a quick win to do somewhat legit persistence, and it does it all for you. So kind of a neat way. One thing you'll notice is that it has an x86 folder, which means it's on a 64-bit system. If it doesn't find that folder, it will do just program files if it's a regular x86 system. So it kind of handles that for you as well. So again, just to wrap up, the code and some of the techniques that we discussed right now and that we released is not cutting-edge rats. We didn't go release a fully functional rat that does everything for you, mainly because we didn't really want to, because that stuff already exists out there, kind of like we talked about Interpreter and Cobalt Strike Beacon. What we really did release is just like an initial, like, hey, here's some initial code that you guys can do really simply and or modify so you can inject shellcode or download and execute these more advanced payloads later so that you don't get caught by AV. So that's kind of the idea of what we want to discuss. And I think these are the code projects that we are releasing. They're all on our GitHub. So Truncer's GitHub is literally Chris Truncer. And mine is Chango 77747. A lot of numbers.
This has all been laid out. If you look, go to the next slide. This is our Twitter account. I just tweeted this so you can have a link to our slides and you can check it out. Again, I apologize for the little bit tiny code pictures that we have in here. But this is where you can go and find all the information. Our slide deck is online. And we really like talking about this stuff. Writing malwares are kind of fun. It's kind of cool to figure out what you can do. And so if you have any questions, hit us up at any time. We enjoy talking about it. So we're happy to but at this point, I guess, is there any questions?
And if not, we'll stick around for a few minutes afterwards if you want to come up personally.
And we'll be here.
I do have a quick question. For all these test rides and stuff like that for Windows machines, so you guys know of actually any systems that are legally set up for testing these on, or do you normally just have to run virtual machines?
We generally just do virtual machines.
Yeah. Other than, if you were to go through like the OffSec course, they have a giant lab that you can for OSCP where you can pay access to.
Yes, sir. Yeah, we've noticed that with RAR files. I'm sure you noticed, like a Tomcat one, for example. Like they have some custom, built-in ones. We just modify the JavaScript within the RAR file. We package the RAR and then upload it. It gets by, every time. But yeah, absolutely, good point.
Well,
All right.
thank you very much.
Thanks, everybody.